Hey everyone, so today I'm going to be solving lead code question 721, accounts merge. I think this is a really good problem. It's different than a lot of um, graph problems that you'll see, and you might not even see that this is a graph question right off the bat. But let me just dive into this question and explain how it works, and then we'll figure out how to reason about it, and then lastly how to implement a solution. Let's make sure we get into a Scala draw. So we're given a list of accounts where each element, accounts I, is a list of strings. Pretty much where the first element is the name and the rest of the elements are emails, and it could be like a long list of emails. So we would like to merge these accounts, and we're essentially given a list of accounts, and we just need to merge them. And then two accounts definitely belong to the same person if they have a common email between both of the accounts. So yeah, note that even if two accounts have the same name, they may belong to different people, as people could have the same name. So a person can have any number of accounts initially, but all their accounts definitely have the same name. That's kind of a let's just go work through an example, and then you'll kind of see what we're trying to do here. With a lot of these coding questions, if you don't understand what's going on, literally just run through an example. So you can see we're given a list of accounts. This is the first element is always the name of a person. And you can see here, this is the first element is John, and it has two emails, John Smith and John New York. And it also has John Smith and John00 Gmail or mail.com. So these two are actually the same person because they share the same common person. So eventually in our output, we need to combine these. Let's do John equals, and then we'll do, so we need to combine this person because this is one person, and eventually output this list of all the emails of this person, unique emails of this person. Mary, this is one person, so it's just gonna pretty much be this. And then finally, John here is actually a different John, right? It's actually a different John. So see how we output John, the first one, and we kind of combine the emails, and Mary's this one, and then we need to be able to group them. So how is this a graph question? So let's like look at this as a graph and go through these emails one by one. So we're given these four accounts, and let's just start building this graph, and then you'll see why it works. So let's say we're gonna have John Smith, or let's do this, John Smith at gmail.com, right? John Smith at gmail.com. We need to build a relationship between all of these different emails. So we could do it as like a bi-directional graph. So John Smith and John New York at gmail.com. We could kind of build it this. And we could kind of say, John, we could build a link here, and we'll say these two are actually both both owned by the same person, right? And then when we move into this one, and then let's go to Mary first. Mary only has one email, so we put Mary here. That isn't linked to any email. Then we'll add John here. Johnny Bravo. These are another email, right? And then let's look at this this second element. John Smith at gmail.com already kind of exists in our graph that we built, but now we have a second email that kind of belongs to it, and we'll put that's John's zero email right there. And we'll say these two link to each other. So you see now, we essentially need to just figure out all of the connected components. So basically cycle through every email and then do a depth first search to find who's fully connected with it. And then we could build these groupings. And then pretty much if we just maintain a name for any of these emails, like a hash map of like email to name, we can just take like one name. We could just take one of the names from any of these. They should have the same name. So we say John00 email mail maps back to John through the hash map. So we'll assign this one John. We'll do the same thing for Mary here. And then we'll do the same thing for John here. You could see, like, pretend that we had another John here, and we had johnnybravo@gmail.com. And then we also had, let's say, Johnny New York here. Right? Now we're going to say Johnny New York actually has an edge, or Johnny Bravo email actually has an edge to Johnny New York. So we'd build this edge right here. And then you could see this all becomes one big connected component. And we could just, yeah, and then you could see that it'll actually be two here. So that's kind of the intuition behind the code, and we just need to figure out how to merge those. So first we're gonna build our graph, and we'll just create something called an adjacency list to store our graph. So adjacency list equals see if I get any messages. So we have an adjacency list, and we're gonna store a adjacency list. It's gonna store a default dict and a set. So what we're gonna store in this adjacency list is a map of nodes. Nodes, and then like a list of neighbors, and we're gonna do a set to make it efficient, to not duplicate neighbors there. And then what we also said is we're going to build a map of like email to name, right? Equals, we'll do from collections import default dict, right? So now we have this adjacency list. What we're going to do is we're going to loop through all the different accounts and sort of build this adjacency list. So how are we going to do that? We're going to say for so in this adjacency list, we're going to, if it's equal to 1, or for the 0th element, we're just gonna add it to the adjacency list, and it's gonna have no neighbors, and then we're gonna add all the neighbors to it. So let's just loop through the accounts. For account in accounts, the name is always going to be account.0, and then what we're gonna do is we're gonna loop for email in account, and we're gonna skip over the first one, and we're gonna skip from the first one, or the first index to the last one, and let's capture the index here. And we'll basically say if the index is equal to 1, this is the first element, we're looking at John Smith 1. What we're gonna do is we're just gonna go to the adjacency list. We're just gonna go into the adjacency list, and for the account at, if the index is 1, what we're gonna do is for that email, we're gonna create, we're just gonna add it in. Let's just not use a default dict here. So let's just not add it here. Adjacency list equals that. For if the index is equal to 1, this is the first one, we're gonna do adjacency email, and we're gonna create the set. These are its neighbors. Otherwise, it's these other ones. We're gonna build that unidirectional. We're gonna build that connection. So what we're gonna do is if email is not in the adjacency list, we're going to do this. We're going to create that email, and then what we're going to want to do the direction both ways. So let's do adjacency list of the email, and then dot add, We're gonna grab account, the first index, because we're gonna make the map to the first index. We're gonna like build the connections there. Adjacency list of account 1. So that builds our adjacency list right there. Then what we're gonna do is we're gonna say email to name, email equals name. That builds the graph that we have right here, and then we just have to start doing our DFS at some point. Let's just print out this adjacency list and see that it's outputting exactly what we want. Saying John Smith has a link to John Smith, New York. How did that work? Oh shoot. So John Smith, yeah, has a link to John. Email. Yeah, John. Let's just make sure this is looking correct for this first input. And most interviews will give you access to Galley Draw. So if John Smith has a link to John email, that makes sense. Bidirectional. John New York has a link to John Smith. John Mail has a access. Mail has access to John Smith. That makes sense. And then my mail, and then we have here. And then we have here. Okay, it pretty much has the same connected components that we mentioned before. Now we just need to perform our DFS. We pretty much have all the emails here, so we're gonna loop through all the emails. So now we're gonna build our final result, and we're gonna probably loop through every single one of the emails and try to do our DFS there. So we'll just do it iteratively. So we'll have our result here, then we'll return our result. Then we'll say for lm in, or for user in email to name. These are all the nodes that we've ever seen. These are all the emails we ever seen. So we're going to go by nodes. We're gonna perform our DFS. Merge accounts. We're gonna have our scene array. And automatically to merge accounts, we're gonna email to name for the specific user. So we get the name, and we're gonna do we're gonna have a stack here. And while stack has results, and what we're gonna do is pretty much if the user is in scene, continue. Otherwise, we're gonna throw the user in here, and we're gonna scene dot add the user. So while the stack is still has results, what we're gonna do is we're gonna get our neighbor, or we're gonna loop through our neighbors. So what we're gonna do is we're gonna be like candidate equals stack dot pop. That'll give us that specific user. Or yeah, that'll give us that specific email, and what we're gonna do is merge accounts dot append the email. Let's say current email. So we add the current email, and then we'll be like for neighbor in adjacency list of the current email. What we're going to do, if neighbor in scene, we continue. Otherwise, what we're going to do is we're going to add it to our stack. And we're going to update our scene array. Something like that. See if this works. Then after we perform our DFS, we're gonna do result dot append the merged account. What do we do here? Does it need to be in some specific order? We didn't merge these properly. Let's debug this. Why didn't it merge properly? We have John Smith and John Zero. That makes sense. Mary's on its own, and then John Bravo is on its own too. So let's see if it ever gets into John Bravo print. Yeah, so it's gonna get John Bravo by itself. Why didn't it get John Bravo before? So when it's gonna go through John Smith first. John Smith has a link to John 00. John 00 is gonna pass. John 00. John 00 has a link to John Smith. Wait, John Smith has a link to John 00. Where's John 0? John 00 has a link to John Smith. John New York has... John Smith should have a link to John New York. John Smith. Oh. Doing count. Let me think. Let me debug this real quick. Index equals 0. So why doesn't John... So let's walk through this line by line. So we have John Smith. John Smith should have a link to John 00 email. And John Smith should have a link to John. There's a small bug here. So we're doing John Smith should have a link to John New York. What's happening here? John New York has a email to John Smith, but not vice versa. Let's do here. It's a good question. Email to I should get these down a lot faster. We're at 20 minutes. John New York to John Smith. John Smith to John New York. Isn't that what I'm doing? What's happening here? Yeah, John New York to John Smith and John Smith to John New York. Am I not updating my list properly? Oh, because I'm resetting the set here. Let's just use default dict. So I don't have to worry about this. Emails are in sorted order. Okay, that's how you solve the question. Oh wow, what happened here? I'll put it. What is this? Oh, I didn't. I have to append it after. Okay. Don't add the email to user right here. Sort the merged accounts and then add that at the end. Something like that. Add these two arrays. Cool. Yeah, that's how you solve the question. Yeah, DFS, build a graph. Basically, it boils down to just connected components after that. And then just choose any email, have a email to name mapping, so you could just give a name for that component. And that's kind of what the name, email to name here, and then all of the elements that are in that sorted component. That's kind of my algo there. I hope y'all learned something. I'll see you on the next video.